Have you ever wanted to import Python code directly from the internet, like from a GitHub repo? Well, now you can, using the magic of cloud imports. Forget the fuss of creating a requirements.txt and installing your dependencies. Just import cloud imports, add your GitHub or other remote repository, and whammo bammo, it just works. This is the real deal, folks. I haven't secretly pre-installed this prime number library in the background. If I remove the repo from cloud imports, we get an import error. Put it back and we're back in business. There are absolutely no downsides to running code directly from the internet. It's fast, it's efficient, it's bleeding edge, and there are no security risks whatsoever. So for the low price of $39.99 a month, okay, hopefully by now you've caught on that this is a joke, and importing code directly from the internet at runtime is, at best, a horribly misguided idea, and at worst, a complete performance and security nightmare. But this code is real. It works. It actually downloads files from GitHub at runtime, dynamically creates modules, and runs the correct code. You can use the inspect module to see the source code, and to your boss's horror, if you ask for the module's file, it gives you the URL where the file was downloaded from. So the real question for this video is, excuse me, what? And to answer this very articulate question, we need to learn about Python's import system. You're no doubt already familiar with how imports normally work. But did you know that Python's import system is accessible from Python itself, and it allows you to customize what the import statement does? This is the purpose of the built-in import lib. To understand import lib, there's just three things you need to know: finders, loaders, and the system metapath. The overview is that you register finders in your metapath, and Python tries each finder in turn until either a finder succeeds or it runs out of finders, in which case you'd get an import error. If a finder succeeds, it gives a specification for the module that includes the loader that should be used to actually create the module. Then Python uses the loader to create and initialize the module. Take a look at the metapath as it is now. The first item in the metapath is a built-in importer, which is used for finding modules built into the Python interpreter itself, like itertools, sys, and time. Then there's this frozen importer, which is used in cases where the interpreter is embedded into a binary, like if you're using PyInstaller. You can ignore that for this video. And the third Pathfinder one implements the usual logic, looking in directories in the system path, which is how Python would find modules in the current directory, modules installed into your virtual env, and built-in modules that were written in Python rather than compiled into the interpreter, like the JSON or inspect modules. All we have to do to get cloud imports is to add another finder to the metapath as a fallback for when Python wouldn't find the module any other way. That's all this add repo function does: add another entry to the metapath. Finders just need to implement one method, findSpec, which takes the dotted name of the module and needs to return a module spec if it can find the module, or none to let the next finder in the metapath have a try. A module spec just holds the loader and some extra info like the module name and whether this module is a package. We implement the cloud finder by replacing dots in Python imports with slashes in URLs, and appending that onto the base URL that the finder was constructed with, like the GitHub repo URL. We go out to the internet and download those URLs and see if we find valid Python source. We check both for .py files as well as for dunder and init.py files one directory down, so that cloud imports work with multiple files and packages, as long as they're written in pure Python. If we find a valid Python file at one of the URLs, then we return a spec for the module that has a custom cloud loader holding the downloaded source code. In the loader, we need to implement create module and exec module, which are kind of like dunder new and dunder init, but for modules. In create module, we create a blank module and add it to the system modules cache, or we get it from the modules cache if it already exists. In exec module, we initialize the module by executing the source code we downloaded within the modules dictionary. This get source isn't required, but it allows the inspect module to find the source of the module as well. And that's it. Add some convenience functions for adding different kinds of repos and you're all set. Zooming out, it's surprisingly little code, under 100 lines, to completely change how Python imports work. Again, cloud imports are a mind-bogglingly bad idea, but I think understanding how to write a cloud importer really helps you understand how the import system works, and in particular, how customizable it actually is. See the import lib docs for more. I'm James Murphy from mCoding, where we do software consulting. Check us out at mcoding.io. As thanks for making it to the end, if you'd like a chance to win a license to JetBrains IDE, make a comment including hashtag mCoding. Thank you to my Patreon subscribers and other donors for supporting the channel. Slap that like button an odd number of times, and I'll see you in the next one.